So let's do example 34.1, where we're going to use the handful of equations that we were given earlier in the lecture. And namely, we're going to use the object-image relationship. These are going to be the main ones you'll use for almost every question in this chapter. The object-image relationship, which can be written in terms of either the focal length or the radius of curvature of the mirror. And that object-image relationship is 1 over the object distance from the mirror plus 1 over the image distance from the mirror, okay? And so let's read the problem. So we have a concave mirror, all right? It forms an image, and that image is on a wall 3 meters in front of the mirror. So 3 meters, the image is 3 meters in front of the mirror, so that's going to be S prime. The object is a headlamp filament that's placed 10 centimeters in front of the mirror. So that is the object distance. And the question is, what's the radius of curvature? That's R. What is the focal length? F. And the lateral magnification, M. And the image height. So the other equation I forgot to write up here, that is basically one of the main, couple of equations you'll be using throughout this whole chapter, is the magnification. The lateral magnification, it can be expressed as negative ratio of image distance over object distance, or image height, I think they use Y, image height over object height. Okay, so we're going to use both of those. So let's go ahead and find out what the focal length or the radius of curvature is. So we can use either form of the object-image relationship. So 1 over S, so that's 3. Okay, 10 centimeters. Do we want to do centimeters or meters? Let's do everything in meters. I'm just more comfortable with meters. Well, that's, okay, well, it doesn't matter, right? It's 1 over S prime plus 1 over S, or 1 over S plus 1 over S prime, but just to keep the same form up here, object distance goes first, image distance. Okay, let's figure out what R is. So 2 over R is going to give me, let's see, we can do a little bit of mental math here. Okay, so that becomes 10. The meters are plus 1/3. So 10 plus 1/3 is 31 over 3. We do a little bit of mental math here, and that becomes, let's see, 31 R equals 6. R is going to equal 6 over 31 meters. 6 over 31 happens to be 0.194 meters, okay? In other words, 19.4 centimeters. So if R is 19.4 centimeters, then F is going to be 2F equals R, right? So F will be R over 2. And thus F will be 19.4 centimeters over 2, which comes out to be about 9.7 centimeters. So the next objective, part B, so that was all part A. Part B, let's find the lateral magnification. So since we know both the object and image distance, we should use that. So we have a negative sign, negative image distance over object distance. Okay, so the lateral magnification is -30. And now we can figure out what the object height is, since we only know the image height. So we know that -30 must equal image height over object height. So we're solving for y prime. This is 5 millimeters, so that's everything in, well, you know, I can actually choose whatever units I want since the left-hand side is unitless. And I can go ahead and leave this as 5 millimeters, and I will know that y prime will be will be in the order of millimeters. So y prime then is going to be negative 30 times 5 millimeters, which is negative 150 millimeters. So that negative sign there means that the image is inverted, okay? And if we look at the picture here, which basically has the solution, you can certainly see the image here. The arrow is pointing down, right? Which means the image is inverted, okay? So, so this is a very good example that it's a simple one because the simplicity comes from the fact that you weren't given R, so knowing the signs of S and S prime give you the sign of R. But in some questions, you'll be given the radius of curvature, but you'll have to decide, is the radius of curvature positive or negative? And that comes into play when looking at the mirror, if it's concave or convex. Okay, so R is less than 0 for a convex mirror. R is positive in this case right here for a concave mirror. Did I say convex here? This is convex. I might have said the wrong word just a second ago. R is less than 0 for convex. R is greater than 0 for concave. Okay, so we'll do another example in the next video.